How's it going, ladies and gentlemen? Good morning, good afternoon, good evening, and good night, wherever and whenever it is that you are watching. And welcome back to Basics. This is episode number 2, titled Letters, Words, and Sentences. Now, to kick things off, I thought I'd put a simple thought in your head, and that is, think about how much reading that you do in an average day. We do a lot of reading as humans, and part of being able to think and to reason is being able to read and understand how words are put together. And furthermore, being able to write and speak those words as well, or to express what you're thinking with words and sentences and letters. Computers are no different. In fact, letters, words, and sentences make up a pretty big portion of programming and representing things with code. And so you may be thinking to yourself, wow, this is a huge thing to be kicking off on, but I promise you, the way that we read and the way that we process words is very similar to the way that computers read and process words. So with that in mind, let's go full steam ahead, as we say, and look at how computers work with letters, words, and sentences. Now, to recant what we were just saying, one of the first things that you learn in school is how to read and write. So it seems natural that we start a series about the basics of programming and computer science off with how computers parse words and sentences. And the good news is, computers parse letters, words, and sentences in the same way that we do, that is, letter by letter and word by word. So let's start with that. Letter by letter. A letter, according to a computer, is called a character, or char for short. On their own, characters are good for representing certain things like initials. So I remember one of the first programming exercises that I ever did, there was a challenge where you had to write a program that took somebody's name and then extract the initials. And naturally, we stored the initials as cars, or chars, as sometimes they're called cars, sometimes they're called chars. I use the two interchangeably, actually. And yeah, so we would store the initials as chars, and that was usually the best way to go about it. Or that's the way that the book wanted us to go about it, rather, I should say. But our language doesn't consist of just letters on their own. We have words as well. And words are known as strings in most programming languages, and strings are comprised of, you guessed it, chars. Pretty straightforward so far, right? We've got letters, we've got words, and just like that, we're only 9 slides in and we're 2/3 of the way there, so we're making great time here. Finally, when you put words together, you get sentences. Now, the good news is sentences are also strings in most languages, so you can store either just a single word into a string, or you can do an entire sentence. This keeps things pretty simple because you can double dip. So you can use, like I said, a string for just a plain old word, or you could use it for a whole sentence, whatever you prefer. So now that we've looked at letters, words, and sentences, and we've kind of got a little bit of a grasp here, why don't we do a quick exercise just to solidify our knowledge? To start off this exercise, we need a famous person, and I think I have just the guy. How about Nikola Tesla? So in case you didn't know, Nikola Tesla was an inventor. He worked on a number of different projects and has hundreds of patents to his name. Tesla is mostly known for his work with alternating current, or AC for short. If you've ever heard about the Current War, which happened in the early 1900s, that was a bit of a scientific bout between Edison and Tesla over which current was better, DC current, direct current, or alternating current, AC. And it's kind of interesting because the two wanted to kill each other over which one was better, but nowadays we actually use both. So there's some applications where DC is better, and then there's some applications where AC is better. If the name Tesla reminds you of cars, you'll be happy to know that Tesla Motors is so named because their cars use AC drive motors, which Nikola Tesla had a hand in inventing, coincidentally, hence why they use Tesla's name for their cars. So, that in mind, what about Tesla can we put into code? What sort of things can we represent, keeping in mind we've been talking about chars and strings? Are there certain things that we can represent about Tesla using those two data types, or those two kinds of things? I'll give you a minute to think about it. So take a minute, pause the video, write out a couple different things that you can represent about Tesla using strings and chars, and then when you're ready, hit that play button. Alrighty, got a pretty nice set there. Perfect. So keep that in mind, have yours set in front of you, and this is what we came up with. So here's some ideas for things that you can represent about Tesla using strings and chars. So we figured out that his first name and last name could both be represented using a string, so those are words, so we can represent them as strings. And then his biological sex can be stored as a char, which is just M for male. So we have Nikola Tesla, both of those are strings for first name and last name respectively. And then his biological sex is stored as a char, which is just the letter M for male. And of course, this is just an example data set. You can add more or less as you like. Now let's look at some pseudocode. What is pseudocode, you might ask? Well, you may be thinking that it's this long, nasty, ugly word that has code in it, but I promise you pseudocode is probably one of the most awesome things in computer science, and we're about to talk about it right now. Pseudocode is a nice way of meeting halfway. Pseudocode is a halfway point between actual code and human-readable text. It's the first draft of your code and just has to show what you're thinking or kind of how you want to outline your thoughts. It's the stuff that you scribble on a napkin in a hurry to remember what you were thinking about and then go and convert it to code later. Pseudocode allows you to lay out your ideas without worrying about syntax. Now, syntax is just the little differences between each programming language. Obviously, there's different ways that different programming languages approach certain things, but pseudocode says, hey, don't worry about that for the time being. Just get your ideas down. As long as it makes sense to you, as long as there's kind of a basic flow to it and you can convert it to code later, you're golden. And that's one of the best parts about pseudocode. There's no right or wrong way. There's no strict set of rules or standards for writing pseudocode. It's just, can you understand it and can you turn it into actual workable code later down the road? So I love pseudocode for that. I don't like having a lot of stringent rules. So pseudocode's perfect for that. So that in mind, here's what we were thinking as far as pseudocode for our example. So the way that we laid things out here is we have the string or char, whichever one it is first, to tell you, hey, this is what we're working with. Then we have the name of the item, so first name, last name, or sex. And then we have its value on the far right. And what separates them is an equal sign. So basically it reads that, hey, this first line says, hey, we have a string. We're going to call it first name, and then we're going to set its value equal to Nikola. We have another line here. It's a string. It's a last name. That's the name of the object. And then we set it equal to Tesla. And finally, we have a character called sex, and it has a value of M for male. So worth noting, this is kind of a breakdown of what we just talked about. So the type of the value goes on the left, at least in our example. The item itself, or the name of the item, goes second, and then the value of that item is on the far right. And then we set everything equal to each other using the equal sign. So this is how most people lay out their pseudocode, but again, if something else makes more sense to you, certainly use that. Now, keeping in mind, if you're taking computer science as like a course and you need the formal names for each of these, then you'll want to look at this slide. The item on the far left is what's known as the data type. So do you have a string or a character? That's the data type. Then the variable that's what we're doing, is we're creating a variable, and the variable has a name. So that's the second item, the variable name. So first name, last name, sex, those are all variable names. And then each variable has a value. So the way that this reads is the first line reads, hey, we've got a variable called first name. It's of type string, so it's a word, and its value is Nikola. The second line reads, hey, we've got a variable of name, last name. It's a string, and we set it equal to Tesla. And then finally, we have a variable named sex. It's of type char or character, so it's one letter, and it has a value of M. So those are the formal names that a lot of computer science teachers or computer science professors will use. So just be familiar with those. And there you go. Now remember, this was just our example. Feel free to change it to your liking. Obviously, if you have a data set in front of you, you may want to write out some pseudocode or write out pseudocode for each one of the items that you created just to get those extra reps and those extra bits of understanding solidified in your mind. Now, to keep in mind what we've been talking about in this episode and what we'll continue to talk about through the rest of the episodes is there are literally an infinite number of ways to solve a programming problem. This has been mathematically proven, and it's a pretty awesome proof if you go out and read it. And all that's to say, Try not to see things as right or wrong. Instead, think in terms of effective and ineffective. So if you're looking at the data set in front of you, it's probably a really great one. After all, you came up with it, and you should be proud of it, but always be thinking to yourself, hey, is this the most effective way that I can use to represent my thoughts or what I'm trying to do? Are any of these points repetitive? Could I condense any of this? Do I need to add anything maybe? If I added another thing or two, would it make understanding or make the data a little bit better? So always be thinking about that. Think about effective versus ineffective. So that'll about wrap it up for this episode. If you guys are feeling good, I hope you're feeling good. Look at that. We've gone through letters, we've gone through words, and we've gone through sentences all in one episode. And we made really good time on it. So great job today, guys. Way to look through everything and kind of keep pace. And as always, examples and practice will always help you with solidifying your understanding. So think of other famous people that you could go through this exercise with, or think of other ways or other things that you can represent with strings and chars and continue to build that reinforcement. Next time around, we will be looking at numbers and math. And as always, hope to see you there. Alrighty, ladies and gentlemen, thank you so much for stopping by and watching our video. We really hope that you learned something today. And if you enjoyed the video, make sure to like, share it out to your friends and any random ninjas that you come across on the sidewalk when you're walking around, and keep the discussion going down in the comment thread by leaving a comment. Also, if you're interested, feel free to subscribe. That way you can get a notification every time we put out a video and be first in the know when we put out new videos and shenanigans and things like that. We hope you'll join us again soon for more steam-powered shenanigans, but until then, have a good morning, good afternoon, good evening, or good night, depending on what time it is whenever you're watching. And as we say around here, full steam ahead.